In this video, we're going to go back over our trig substitution. And so the first thing that I want you to recall is that if you have some sort of square root of a squared minus x squared, then we know we're going to try and use x equals a sine theta for our substitution. So here I'd actually recognize that, okay, 16 is really 4 squared. So the substitution that we're going to try and use is x equals 4 sine theta. Okay? If x equals 4 sine theta, we also have to replace this dx. And so dx, if we take the derivative of this right side, would be 4 cosine theta d theta. So that's the substitution that we're going to use. We're going to use x equals 4 sine theta and dx is 4 cosine theta d theta. So let's input those for x and dx. We would rewrite this then as 1 over the square root of 16 minus 4 sine theta squared. And then we'd replace dx with 4 cosine theta d theta. Alright, so let's try and simplify this a little bit. We would have 1 over the square root of 16 minus 16 sine squared theta times 4 cosine theta d theta. Okay, the next thing I'd recognize, the square root of 16 is 4, and we've got 16 and 16. So we can actually factor out a 4 there. So 1 over 4 square root. And so really, I factored out a 16 and took the square root of it to get 4. So really I have 1 minus 1 sine squared theta. And then we've got 4 cosine theta d theta on top. Okay, well that works out good now because 4 and 4 would cancel. Alright? The next thing that I'd want to recognize, because of the fact that cosine squared theta plus sine squared theta equals 1, cosine squared theta really equals 1 minus sine squared theta. So I'm going to replace this 1 minus sine squared theta with cosine squared theta. So I've got 1 over the square root. I'm replacing 1 minus sine squared theta with a square root of cosine squared theta. And then we've got times cosine theta d theta. Okay? So, multiplying that out, I'd have cosine theta on top. And on the bottom, the square root of cosine squared would also again be cosine d theta. Cosine over cosine would be 1 d theta. And if we integrate 1, it would just be what the variable is. And right now we're integrating in terms of theta. So if we integrate 1 d theta, we get theta plus c. But our original problem was x. We don't want x, we don't want theta. We want an x. So let's look at this x equals 4 sine theta and see if we can somehow get theta to actually be x. So I'm going to slide that down here. If x equals 4 sine theta, we can divide by 4. X over 4 equals sine theta. And then we take the arc sine of each side to undo this. So arc sine x over 4 is actually theta. We want to replace that there. So plugging that back in, we get a final result of arc sine x over 4 plus c. Alright, now let's look at a tan substitution. Now I gave you this identity here. This actually is not going to be the most helpful one. Sometimes in tan substitutions that's a really helpful one, but in this case we're gonna make a couple other notes of some helpful ones. And the first one being, we want to note tan squared theta is the same thing as sine squared theta over cosine squared theta. You'll see that one be useful in a minute. And also from our previous example, again, sine squared theta plus cosine squared theta equals 1. Both those are going to come up in this example. So I gave you the hint. We're going to use x equals 5 tan theta for our substitution here. So let's rewrite this and see what we have so far. I'm going to go ahead and let's take out that 4. And let's plug in our x. 5 tan theta plus 25. And we should probably note we need to also replace that the dx value. If x was 5 tan theta, dx is going to be 5 over, and the derivative of tangent is 1 over cosine squared. So we'd have 5 over cosine squared theta d theta. So times 5 over cosine squared theta d theta. I'll just put a little barrier there. Okay, so there's our new setup. And this is squared. If I simplify that out, we're going to have 4 times 1 over 25 tan squared theta plus 25 times 5 over cosine squared theta d theta. Notice how both these have a 25. I could factor that out. So 1 over 25 times tan squared theta plus 1 times 5 over cosine squared theta d theta. Now 5 and 25, those would simplify really to 1/5, right? 1 on the top and 5 on the bottom. So I can technically take out a 1/5, which would give me 4 over 5 times 1 over tan squared theta plus 1 times 1 over cosine squared theta d theta. Now, see how we had this note up here in our upper right that tangent is really sine squared theta over cosine squared theta? I'm going to replace tangent squared theta with that. So 4 over 5 times 1 over sine squared theta over cosine squared theta plus 1 times 1 over cosine squared theta d theta. Now if I distributed this cosine squared theta in, if I distribute that to both of these terms, we'd have 4 over 5. Cosine squared would cancel out there. So 1 over sine squared theta. And if I distribute cosine squared also to that 1, plus cosine squared theta d theta. Now we should notice sine squared theta plus cosine squared theta. That can be turned into just 1, right? So 4 over 5 times 1 over 1 d theta. And if we integrated that, we're going to get 4 over 5 theta plus c. So similarly to what we did with the arc sine, we need to replace theta with an x. So let's pull that down. If x equals 5 tan theta, solving that for x, we can divide by 5. X over 5 equals tan theta. So arctan x over 5 is theta. If we plug that back in, our final answer is 4 over 5 arctan x over 5 plus c.